Okay, so in this video, we're going to talk about reference angles, and I'm going to show you the easiest way to deal with reference angles. So before we even talk about reference angles, we will first need to talk about the quadrants. And in our axis, we have 4 quadrants. So we're going to start here, and we always read our quadrants counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. And our angles start off at 0 here. Then we have 90 over here. We have 180 over here. 270 degrees over here. Let's put the degrees here just so that you can see what we're referring to. And back here we have 360 degrees. And so let's start off with using degrees to figure out what reference angles are going to be. So let's start off with, let's say we have an angle of 45 degrees. So I'm making a good habit to always draw the axis here. And 45 degrees, we start off at 0. Remember, this is 0, 90, 180, 270, and then 360. Always a good habit to start this way. And we're going to 45 degrees, and I said we have to go counterclockwise, which means going in that direction. So we're going to go counterclockwise until we get to 45. It's going to be between 0 and 90. And so this is going to be 45 degrees. Now, important thing to know and to remember when you're talking about reference angles is that your reference angle must always form with the x-axis. The reference angle forms with the x-axis. So this is 45 degrees. And you can see here that because it forms with the x-axis, it's going to be just 45 degrees. So here, our reference angle is also 45 degrees. Now, what about if we had something like 125 degrees? We start off the same way. This is 0, this is 90, this is 180, 270, and then 360. Repetition always helps. So we want to get to 125 degrees. So we start off with here. We go to 90. We need 125. So we know we're going to be between 90 and 180. So we're going to draw an angle right here. And you're going to see that this angle does not form with the x-axis only. You can see there's a x-axis part and a y-axis part of this angle. So what we're going to do is we're going to find the part of the angle that only forms with the x-axis. So that is going to be that angle. And how do we get the reference angle? It's going to be 180 because we're trying to get this part of the angle. So it's going to be 180 degrees minus 125 degrees, which is going to be 55 degrees. So your reference angle is 55 degrees. Now let's try another angle here. Let's get another angle here. We're going to try an angle like 217 degrees. Let's try that. 217 degrees. So we start off the same way. 0, 90, 180, 270, and then 360. So we want to get to 217 degrees. We start our direction counterclockwise. And we go here. This is 180. This is 217 is going to be between 180 and 270. So we are going to draw an angle here. And we can see here that this angle, you can see this is the part that forms directly with the x-axis. So that is the portion that we're going to care about. So what do we see here? We see that this is 217 degrees and this is 180. So this part of the angle is the one that will make our reference angle. So our reference angle is going to be 217 degrees minus 180 degrees, which is equal to 37 degrees. So our reference angle here is 37 degrees. Now, what if we had another angle? Let's go with 306 degrees. So start again the same way: 0, 90, 180, 270, and then 360. So now we're going to try to figure out our reference angle. So we go counterclockwise: 0 to 90, 180, 270. Our angle is going to be in this quadrant, the fourth quadrant. So this is going to be 306 degrees. Now we are saying that the angle we need must always form with the x-axis. So it's going to be this angle right here. So we have 306 all the way to 360. So this is going to be reference angle is going to be 360 degrees minus 306 degrees, which is equal to 54 degrees. Now we're going to do one where the reference angle is actually greater than 300, the angle we're trying to find is actually greater than 360 degrees. And then we're going to see how to go about those type of angles so that we can have some completeness here. So what if the angle we're working with is 537 degrees? So we're going to draw our axis here. Start at 0, 90, 180, 270, 360. Now, but we need to get to 537. So now we're going to go all the way to 360. So that is not yet 537. Now, when we get to 360, this angle will be 450. And then this here is going to give you 540. So this is, we get to 360. Why is it 450? Because you add 90 to that. So this is 450. And then we go to 5, this is 540, but we want 537. So that is this angle right here, which is 537 degrees. But if you look here, after you get to 450, the next one is 540. So 537, but we need this angle to form right here. So this is going to be, reference angle here is going to be 540 minus 537 degrees, so which is equal to 3 degrees. So for 537 degrees, your reference angle is going to be 3 degrees. Okay, so now that we've done all of this, I want to show you some general practice, some general rules that you can come up with. So we talk about the quadrants. Let's start with quadrant 1. Quadrant 1, our reference angle is always going to be equal to the angle that we're given. That is if the angle is in the first quadrant. Now, quadrant 2, your reference angle is always going to be 180 degrees minus the angle that you're given. Quadrant 3, your reference angle is going to be the angle that you're given minus 180 degrees. And then quadrant 4, your reference angle is always going to be 360 degrees minus the angle that you're given. Now you may wonder, what about radians? If the angles are given in radians, what do? We do very similar things. First thing, let's try an angle like 2 pi over 3, for example. So let's start with our axis again, but this time in radians. This is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Now, some may wonder how to work with this right here. So what I tend to do, some students like to convert to decimal. I don't like decimals too. I don't think it's a good idea to always do that because a lot of times when you're learning this topic is in pre-calculus, and you may not be allowed the benefit of using a calculator. So what I like to do here is I can convert all of this to a common I can convert all of this to a common denominator. That's if you don't know how to approximate these angles. So if I look at this, for example, I can see that 2 pi over 3 is, we can ignore pi for once and just look at the fractions here. This is 1/2, this is 2/3. If you understand your fractions, you can see that 2/3 is much larger than 1/2. So that means that 2 pi over 3 is going to be in the quadrant past pi over 2. So how do we get that? We come over here, and this is where 2 pi over 3 is going to be. So 2 pi over 3. And we need to find the angle that forms only with the x-axis. And so to get that, we're going to have pi minus 2 pi over 3. And just as a trick that I use for fractions, make this over 1, then you multiply that way, multiply that way, multiply that way. So this is going to be 3 multiplied by pi minus 1 multiplied by 2 pi divided by 3 multiplied by 1. So this is going to be pi over 3. That's going to be our reference angle. Let's try another example. Example we're going to try next is going to be most likely 5 pi over 4. Let's try 5 pi over 4. And if you look at 5 pi over 4, let's write the angle 5 pi over 4. So if I draw my quadrant here, so this is 0, this is pi over 2, this is pi, this is 3 pi over 2. Now, when you have an even denominator, it's a lot easier to figure out how to rewrite all of this. So, and this is 2 pi. So pi over 2 is going to be the same as 2 pi over 4. Pi is going to be the same as 4 pi over 4. And 3 pi over 2 is going to be the same as 6 pi over 4. So, if you look at 5 pi over 4 without even doing these approximations or conversions, you can see that this is greater than 4. So you can already tell that this is past pi. So this is going to be 0, and then this is pi, and then we have 5 pi over 4 right here. So 5 pi over 4, this is going to be the angle that we're looking for. Our reference angle is going to be right here. So this is going to be, let's write this, 5 pi over 4. So this will be reference angle. It's going to be 5 pi over 4 minus pi, and then you can put over 1 here. And then we do a cross multiplication right here, and right here. So this is going to give us 5 pi multiplied by 1, 5 pi, minus 4 multiplied by pi, which is 4 pi, divided by 4, and this is going to be pi over 4. Now that we've done some angle examples in radians and degrees, now we'll come up with some interesting rules also based off of what I showed you for degrees. So if we have quadrant 1, the angle with reference angle is always going to be the angle that we're given in radians. Quadrant 2, we're always going to get reference angle is pi minus the angle we're given in radians. And then quadrant 3, the reference angle is going to be the angle we're given in radians minus pi. And then quadrant 4, the reference angle is going to be the angle, it's going to be 2 pi minus the angle that we're given in radians. Now, what if we had an angle that is much greater than 2 pi? because remember, our quadrant goes from 0 to 2 pi. Our coordinates go from 0 to 2 pi. So, what if we had something like, let's go with 11 over 4 pi. So the first thing I will do here, once you see that the value over here is greater than the denominator here, so your numerator is greater than your denominator, just go ahead and simplify it. So this is going to be 11 divided by 4. So we have 2 here, and then 2 multiplied by 4, 8, 3. So this is 3 over 4 pi. So what this is going to be 2 pi plus 3 over 4 pi. All right, so now we're going to go draw our axis here. We'll draw a quadrant. So this is 0, pi over 2. This is pi, 3 pi over 2. And then this is going to be 2 pi. So when we go around all our quadrants once, we get to 2 pi. So, but we need to go past 2 pi, and then we need to get to 3 over 4 pi. 3 over 4 pi is going to be much larger than pi over 2. So we're going to continue past this first quadrant again and come over to this quadrant. And I'm just going to use 3 pi over 4 right here. Because 3 pi over 4, after we complete one revolution or one cycle around the quadrant, we have to go this angle right here. So that is 3 pi over 4. And remember earlier I showed you with the quadrant, when you're in quadrant 2, you're going to have pi minus the angle, which is 3 pi over 4. We divide. So let's do a cross product here. So the cross product, cross, and then cross again. So 4 multiplied by pi is 4 pi, minus 1 multiplied by 3 pi is 3 pi, divided by 1 multiplied by 4, which is 4. So this is going to be 4 pi minus 3 pi, which is pi over 4. So this is generally how you can walk through this type of problems. We can go through so many other examples, but this should give you a starting point as you learn about navigating the concept of reference angles.